Hello, my dear students. I hope all of you are keeping well. Today, I would like to begin with a new chapter in chemistry, that is chapter 5, the periodic table. Before I start this chapter, I would like to take few examples. Suppose when you go to the medical stores and ask medicines to chemist, they bring the medicines within a fraction of a second because all the medicines which are in medical store are kept in a proper way. You think if those medicines are mixed with each other and kept in a random way, his work will be very difficult. Similarly, at home, your mother used to keep all the dresses in almirah in proper way, which makes her work easier. As you know that we are surrounded by many substances. All these substances are matter. Scientists they divided this matter into three categories: elements, compounds, and mixture. There are 118 elements known to us. Now it is clear for you why do we need to classify the elements. We need to classify the element because it makes our study easier and systematic. Many scientists they attempted to classify the element in different ways to make their study easier and systematic. See, all chemists, this was the portion who dealt with chemicals in the ancient time. They classify the elements as metals, non-metals, noble metals or base metals, etc. Then later on Daubigny, he classified the elements in group of three, which is known as Daubigny's tract. And he found the atomic mass of middle element is almost equal to the average atomic masses of other two elements. Now here lithium, sodium and potassium, this is an example of Daubigny triads. You can see here lithium atomic weight is 7, sodium is 23 and potassium is 39. Their average atomic masses is 23, which is the atomic weight of sodium. His law was discarded because he was unable to classify all the known elements as triads. Then later on, John Newland came. He ordered the elements in group of 8 in the increasing order of their atomic weights. As you know that in the musical note, in Indian musical note, sa, re, ga, ma, pa, dha, ni, sa. Sa is repeated here, that is 8th note. In Western note, do, re, mi, fa, sol, la, ti. Again, do. Do is repeated. Similarly, when he ordered these elements in group of 8, he found that after every 7th element, that is 8th element, has similar properties with the starting element. Here, hydrogen 1, 2, lithium 2, beryllium 3, boron 4, carbon 5, nitrogen 6, oxygen 7 and fluorine 8. Here the properties of fluorine are similar with the properties of hydrogen. Next, carbon here 1, 2, 3, 4, 5, 6, 7, 8. Silicon. The properties of silicon are similar with the properties of carbon. Here, Newland's law of octets also discarded because his law was only applicable to calcium. Beyond calcium, 8 elements did not possess the similar properties